I'm Anil Kumar, and here is an application on exponential functions. The question here is, a bacteria culture starts at 1000 bacteria, and after 3 hours the estimated count is 4000. Find the number of bacteria after t hours, find the number of bacteria after 2 hours, and find rate of growth after 2 hours. So let us first develop an exponential function to represent the given situation. Now, since the number of bacteria increases based on their population, it could be represented by an exponential function. So we can write this as the number of bacteria f of t with respect to time is equal to initial population of 1000, right? So it is 1000 is the initial population, e to the power of kt. To find the constant k, we can use the information that after 3 hours, estimated count is 4000. So 4000 is f of t. After 3 hours, t is 3. So we could write this as 1000 e to the power of k times 3. Now simplifying, we get 4000 divided by 1000 as 4 equals to e to the power of 3k. To find k, we can take ln on both sides, the natural log. So ln 4 is equals to ln will give us 3k here, right? So 3k. So k, the constant, is equals to ln 4 over 3. Now that gives us the required equation. So now let me write down the equation. So the equation for us is f of t equals to 1000 e to the power of ln 4 over 3, or I could write t over 3 times, or let us say over 3 times t, either way. So that is the required equation. Now at times you could also write this equation as, let me write it in alternate way, f of t is equals to 1000 e to the power of ln 4 is 4, right? So it could be written as 4 to the power of t over 3. So that's an alternate way of writing the same equation, right? Let us now do part B, which is find the number of bacteria after 2 hours. That means we have to write f t is 2 hours. We can write 2 there, right? 1000 times 4 to the power of 2 over 3. So that gives us, so we have 1000 within brackets 4 exponent 2 over 3. So we'll put brackets there. 2 divided by 3, bracket close, equals to 2519.8. So 2519. So let's write 2519, right? So that is the count. Let us redo these calculations using that equation. So this time I'll use this particular equation. So what we can do is we can find f of 2 as equals to 1000 e to the power of ln 4 over 3 times 2. Okay, so we'll use calculator again, use this calculation. So 1000 within brackets e to the power of, so within brackets we have 2 times ln 4, right? So we could do divide by 3, right? So or we could say within brackets ln 4 bracket close times 2 divided by 3 bracket close. Okay, 2519.8, right? So we get exactly the same value, correct? So both are same things. It's kind of important for me to show you that it is indeed the same thing, right? Now, but this is simpler to deal with, correct? So either way, let's continue with this operation. Okay. Part C is find the rate of growth after 2 hours. Now for rate of growth, let us use the function f of t as equals to 1000 e to the power of ln 4 over 3 times t, right? Now f prime t, the rate of growth, will be 1000 times this function itself, which is ln 4 over 3 times t, times derivative of this function. So derivative of this will be ln 4 over 3, right? So that becomes your derivative, and you need to find the rate of growth after 2 hours. So that means f prime of 2 is equals to how much? Substitute 2 here now. So when you do, this part is 1000 e to the power of ln 4 times, let's say 2 over 3 times ln 4 over 3, correct? That is what it is. We already found this value, ln 4 times 2 over 3 as 2519. We'll multiply that by ln 4 divide by 3. Okay, so we can do that. So this is equals to, we'll use the same value, 2519.84, which we calculated for the first part, right? And we can divide this by 3 and then multiply by ln 4 to get the result, right? So that gives us the answer as 1164.4, right? So rate of change at this point is so many bacteria per hour, right? So this is so many bacteria per hour, right? So we get our answer, and that is f prime 2 is equals to 1164 bacteria per hour, right? So I hope you understand and appreciate how to use exponential functions to answer, right? Since the derivative of exponential function is the same as exponential function, even in calculations, right, as we use, you could use the same calculations and then, do needful to get the right answer. I hope that strategy helps. Thank you and all the best.